integration. But this time we want to rotate around the line y equals 1 in this case. Okay. So same process, right? So let me just quickly draw this over. Actually, a little different. There's going to be 1. All right, so here's, let's say this is 1, so this is 1/2 here. So that's where they cross. Here's our line we're bounding from. And we're rotating around this way. So if we rotate it, it's actually going to loop up to 2 over here and come back down. So this is our region we're actually looking for right here. Like that-ish. It comes to it. Okay. So we're rotating our circle like this. That's going to be our disc, or a washer in this case, when it comes to it. Okay. All right, so same process we did above. It's going to be the volume is equal integral from 0 to 1/2 of the outer region. So the outer region now in this case, it's going to be this curve, which is going to be 2x squared minus the inner region, which is going to be x squared. Now, unfortunately, that's actually incorrect. The reason for that is, you got to be very careful, is this only applies when we've only gone through the x or y regions, right? So on the actual axes themselves. But this time we're rotating something different, a different kind of concept altogether as well. Okay, so when we do that, is a little different, because now we actually want to find the radius from here all the way to there. And notice that's from here is 1 minus this distance. So the actual radius of the outer one is going to be 1 minus 2x squared. And then the inner one is going to be 1 minus, when it touches this line, of just x. So that's our actual inner and outer radius. So you got to be very careful when it comes to rotating this way. When it comes to it. So that corresponds, if it's like 2 or 3, you would do 3 minus the portions, and you go down here. We'll talk about that when if it's a little down here above that way when it comes to it. Just got to be very careful how you abbreviate the actual radius of this entire disk itself. Okay. And now we'll just simplify this as much as we can. So this is equal to pi on the outside, integral from 1/2 of, and just simplifying this gives you 1 minus 4x squared plus 4x to the 4th, and this gives us this on this side. And then putting everything together, gives us that. Okay. And then this is pretty straightforward, right? We just take the integral each individually. So it's going to be 4x to the 5th over 5 minus 5x to the 3rd over 3 plus x squared evaluated at 1/2 pi, right? Because 0 doesn't matter. This all goes to 0 itself, right? So we just plug in 1/2 in each individual case and just simplify. So this ends up being 4/5 times 1 over to the 5th, that's 32, minus 5/3 times 1/8, plus 1/4 all times the pi. So simplify this a little bit more. This gives you 8, so this is 1 over 40 minus 5 over 24 plus 1/4. And then multiplying or adding all that fun stuff together gives you the answer we're looking for as our volume. So again, a little different example than example 3, because now we're rotating on a different line, not just the x-axis or the y-axis itself. Okay. Now let's go on to example 5. So example 5 now says, well, let's rotate this around the line y equals -1 now. Okay. So how that's going to work. So again, let's kind of draw this and see what's actually happening. So same process. This is still going to be that our rotation here. So now this is going to be the line we rotate about. So if we rotate it this way now, this is going to go all the way to 2, or negative 2, and now look like this. So our sphere, or our solid, looks like a big old drum, if you want to call it, but it's empty on the inside. Big old empty drum. Okay? This is the thickness of the drum itself. Okay? So therefore, now we have our washer going in this direction. Like that. So which means, since our washer is going this way, right, this is perpendicular to the y-axis, so therefore, now this is going to be integration with respect to y this time. Right? So we have to change all our values when it comes to it. So we know y equals x, just x equals y. But for the other one, we have to solve for x itself. So dividing and taking the square root, we know x is equal to the square root of y over 2. Okay? And that's this portion here. So now, do the same thing. So our volume is equal to pi times the integral. And now we're bounding from our y value, so from 0 to what value here is going to represent itself. So we know this is 1/2, so if I plug in 1/2, that's also 1/2. It's kind of nice. So those are also still bounds. So we know it crosses the y-axis at 1/2 as well. Right, that's where they intersect. And now for the outer radius, it's going to be this one, which is here. However, unlike the last one where we have to subtract 1, here we actually add 1. It's going to be this additional with that, right? So it's not all the way over here. It's 1 plus this portion. Now this is going to be 1 plus the square root of y over 2 squared minus, again, from here to there, it's going to be 1 plus that difference. So it's going to be 1 plus, in this case, y. And there's our integration portion. So same thing, just to slowly simplify as best you can. So this ends up being this so far. And again, simplifying a little bit more. Gives us that. Okay. And now finally, we just take the integral. Unfortunately, right, this makes it look kind of messy, and it is kind of messy for a reason. It's actually the substitution method. So we're going to have to let u equal y over 2. Therefore, du is just 1/2 dy, which is no good because we don't have a half out there. We actually have a 2. So we have to multiply by 4 to get that 2 out there. So we'll just work on this real quick. Those are pretty straightforward. So this ends up being 4 integral of u to the 1/2 du. So this is just u to the 3/2 over 2 over 3 times 4. So plugging back in, this is going to be 8 over 3 times u to the 3/4, so times y over 2 to the 3/2 power, and everything else we just bring down accordingly, right? So this can be minus y to the 3rd over 3 minus y squared over 4, evaluated at 0 and 1/2 pi. And same thing, we just plug in 1/2 and see what do we actually get, right, when it comes to it. So this one is a little bit more trickier when it comes to it. So plug in 1/2 or 0.5 if it's easier. This gives you, we just use a calculator to help ourselves when it comes to it. Okay, so this will be 0.333 minus, let's see what we get here. Point 0.0417, and then minus 0.1875, and then we just do all those. So 0.333 minus 0.0417 minus 0.1875 gives us approximately, that is our volume.